Good afternoon everyone. I am Daisy Sharma from the Department of Computer Science, USTM, and today I am going to present the topic of relational operator which comes in the Relational Database Management System. This is the course name, and the course code is BCA 304, that is under BCA third semester, and this relational operation is under unit number 2. So, let us start with this topic. So, relational operation, it is very simple but restricted data structure which is very useful in case of relational database, and this relational operation can be performed by using relational algebra. Let us start with the relational algebra now. So, relational algebra, it is one kind of procedural query language where relation is taking as an input and the relation is coming out as the output also, but in between this the processing goes on. Now, there are some basic type of operators which are used in this relational algebra, and the operators are these are the operators. Total 9 operators are there for relational operations under relational algebra, and the operators are selection, projection, product or cross product, then join, union, intersect, difference or minus, rename and divide. So, I have taken here as consideration tables, some of the tables here. So, first table is the student sports table where we are having 2 fields, roll number and sports. So, here 4 roll numbers I have taken, but 2 roll numbers are same, that is roll number 2, but the sports are different. For roll number 1, it means this table means actually which student is playing which sport. So, here roll number 1 is playing badminton, roll number 2 is playing cricket as well as badminton, and roll number 4 is playing badminton. This is table number 1. Then table number 2 is about employee. Here we are having total employee number, employee name, address, phone number and age, 5 attributes or fields and 4 records for roll number 1, for roll number 5, for roll number 6 and for roll number 4. So, these are the records of employee. Next table is the student table which is having roll number, name, address. In case of employee it is not roll number, it is employee number. Then in case of student it is roll number, name, address, phone number and age, 5 attributes and 4 records here for roll number 1, 2, 3 and 4. Then all sports, in this all sports here table number 4 is having the sports available in that college or university. So, 2 sports are available, one is badminton and another one is cricket. So, these 4 tables we have considered here as example, and based on these 4 tables we are going to calculate the relational operators. So, first one is the selection operator. So, this selection operator, it is mainly given by using the symbol sigma. This selection operator is used to select multiple tuples from a relation based on some condition. It takes the condition, and based on the condition the table contents the content of the relation, it gives the result. So, this is the syntax. Firstly we have to give the sigma, then within bracket here we have to give the condition, and then we have to give here the relation name. The condition comes in the subsequent part. Next is, this is the example. In this example, if we see that we are going to extract the student whose age is greater than 18 from the student relation given in table 3. So, let us see the table first, the table number 3, this is the student table. So, here we are having roll number, name, address, phone number and age. So, we have to extract here the roll number, that student table, the values of the student table whose age is more than 16. So, here we are having all the values are more than 16 now. So, as per this here extract as per this we have to greater than not 16, 18. So, as per this table content here roll number 3 is having is satisfying this condition. So, therefore, we have to write here selection the selection operator, then within bracket we have to give the condition that age is greater than 18, and which relation is this? This is the student relation, and based upon this the result will be displayed as roll number 3, name is Sujit, address is Rohtak, phone number is this one, and age is 20. But other 3 records will not be displayed because age is not more than 18. So, this is the selection operation where we are getting the whole record based upon the condition. Now, let us come to the next operator, that is the projection operator, and this operator is used to project particular columns for a relation. It does not display directly the whole relation or the whole row, but it displays the column, and the syntax is, for this we have to use the symbol pi, then we have to mention here the column number in the sense column names, and in the subset part, and here now in the relation name should come here. For this, the example we are giving here is to extract the roll number and name of the students in relation number 3, that is the table number 3, which is student table. So, here we have to write pi, then roll number comma name from the student. So, as a result it will display all the roll numbers and names present in table number 3. So, if we see the original table number 3, here this is the student table where roll number 1, 2, 3, 4 and the name Ram, Ramesh, Sujit and Suresh, for them these records are coming. We can display more fields also, but we cannot put the condition in the projection operation. So, this is the result we are getting. After this, right after this, next is cross product or the product. So, this cross product or product is used to join 2 relations, means if we have 2 relations or 2 tables, then we can join by using this product operator. So, here every row in relation 1 will be joined with relation 2 and they are concatenated, and the symbol is cross. So, here the syntax is, first we have to give the name of first relation cross second relation. As an example, if we see, we are going to join the 2 tables, one is the student table and another one is the student sports table, and the example is to apply cross product on student relation given in table 1 and student sports in table 2. That means, we are going to make this product relation for table 1 student and table 2 student sports. And the result, before showing the result, let me show you the 2 tables, student table and student sports table. So, let me show you, this is student sports table, table 1 and student table, table 3. So, if we see this 2 table, we are going to display the values here. So, it is displaying like this. 1 is coming for 4 times, because in student sports table 4 records were present. So, that is why same values are coming. This 1 is coming from here. Wait, let me show you. It's okay, no problem. So, here 1 Ram, Delhi, this values are coming from student table, and roll number and sports values are coming from the student sports table. So, if we see carefully, then this roll number and sports values are changing in 4 records, but they are not changing in this part because they are multiplied. In the same way, the second one, number 2, Ramesh, is coming for 2 times here, or 4 times here, but from the student sports table, roll number 1, 2, 2 and 4, they are coming. So, this all records are cross product values. So, this is the cross product. So, if the first table is having 4 records and the second table is having 2 records, then 4 into 2 equals to, we will get 8 records at a time, and that is what we are getting here. If we count 1, 2, 3, 4, 5, 6, 7, 8, we are getting 8 records. This is the result of the cross product. Next, let us go to the next one, and here see, we are since in table number 3, the student table are having total 4 records. So, that is why 4 into 4 equals to 16 records we are getting here. We are getting the result of 16 records. So, this is the cross product. After this, next is union and the symbol is U. So, this is just like the set theory of union, where we can use this union operator in two relations, and we will get the output as the values of both the tables, both common as well as uncommon values. Means it will display all the values at a time if we use the union operator. So, here we are joining, or not joining, actually we are going to use this union operator for these two tables, one is student and one is employee. So, in the student table the values are coming here, as well as the employee table values are also coming here. We are not displaying the roll number or employee number, we are simply displaying name, address, phone number and age. So, the values are coming like this. If we see the contents of student and employee table, let me show you. This is student table where the names are Ram, Ramesh, Sujit and Suresh, and where the employee table Ram, Naresh, Shweta and Suresh. Ram, Naresh, Shweta, Suresh, and here Ram, Ramesh, Sujit and Suresh. So, if we use this union operator, so the values are like this: Ram, Ramesh, Sujit, Suresh and Shweta. So, all these values are coming, Naresh, Shweta, all these values are coming here. But when we have the common fields or the common values, it will come for only one time, not more than one time. So, this is the union operator. Now, let us come to the intersect operator. So, intersect operator displays the result for only the common value. The uncommon values will not be showed for two relations, and the symbol is reverse U. So, in our two tables, the same table student and employee, two values are same, that is Ram and Suresh. These two records are present in both the tables, student as well as employee. So, it is displaying the records of Ram and Suresh only. So, this is the record of the intersect operator. Now, let us come to the next one, that is minus operator. So, minus operator is what? That this is also used in the in two relations. So, here if we say R1 one relation and R2 as another relation, then R1 minus R2 means something which is present in R1, but that is which is not present in R2. So, that is the minus operator. In case of union and intersect operator, if we give R1 union R2, the result of R1 union R2 is same with the R2 union R1. Same thing happens in case of the intersect operator also. But in case of minus operator, here it is something different. R1 minus R2 is not equals to R2 minus R1. So, here we are giving here student minus employee, means something which is present in student, but not present in employee. So, as a result we are getting this Ramesh and Sujit, these two were not present in the employee, present which is present in Suresh, but not in employee. So, we are getting these records. Next is the join operation. So, join is the combination of Cartesian product or cross product from by the selection operation. So, this join operation means it is the combination of the cross product with the selection operation, and this join operator it pairs two tuples togetherly from different relation, and if it will be combined together only if the join condition is satisfied. It takes the condition, based on the condition the joining is performed. Now, let us come to the types of join operation in relational algebra. So, various joins are used, and the symbol of join is just like the dumbbell, a horizontal dumbbell shape. So, these are the types of joins: conditional join, which is given by using the horizontal dumbbell shape, and below there is one C. Then equijoin, then natural join, left outer join, right outer join, full outer join. The symbols are different for each and every, though it is in the dumbbell shape. So let's start with the conditional join operator. So this conditional join operator is used when we want to join two or more relations based on the same condition. That means if the condition is same for both the relation, then we can make this conditional join operator. For example, if we select the student whose roll number is greater than employee number of employee. So for this we are giving this join operation, firstly student table, then the join operation, then see condition is student dot roll number which is greater than employee dot employee number, and this is the employee table. So these two tables are involved simultaneously with the join operation, where the condition is student's roll number should be greater than the employee's employee number. So based on this it will display the result. So this result will be displayed based on the student's roll number and employee's employee number, the particular condition if it is satisfying, and if the condition is not satisfying, then what will happen? Nothing will be displayed, we will get the null value. Next is the result. If we see here, based on this condition, student roll number is greater than employee's employee number. So this roll number, name, address, phone number and age, these things are coming from student table, and employee number, name, address, phone number and age, these things are coming from the employee table. And the result, if we see, roll number when it is coming as 2, where employee number is 1, 2 is greater than 1, condition is satisfied. So that's why it is displaying the record of both the tables. Same thing, roll number 3, the next record roll number 3, here this 3 is more than employee number 1 again, so it is displaying the record of both of them. Then roll number 4 is greater than employee number 1 again, so 1 it is displaying this results, and here the roll number 4's records are displayed from the student table, where employee number 1's records are displayed from the employee table. Let's come to the equijoin, next one. So equijoin is a special case of conditional join where only equality condition holds the pair of attributes. So here the condition, it takes the condition, but the condition should be only equals to. No greater than, no less than, no not equals to, only equals to condition is checked. So if we take this example, then this example select student's roll number is equal to employee number. That means here our example here, student, this is the join operation, no C, C should not be here because this is not the conditional join, this is the join, simply equijoin. So in equijoin simply the dumbbell shape is used. Then student dot roll number is equals to employee dot employee number, and the table is employee here at the right hand side. And the result it is displaying here, roll number 1, name Ram, address Delhi, phone number this one, age 18. These things are coming here from employee table, student table, and name, address, phone number, age, these things are coming from the which table? That is the employee table. So combination of these two contents are coming here, where roll number and the employee number are same, but the employee number is not displayed here particularly, but they are same. After this now, next is the natural join. So it is a special case kind of equijoin which is used for equality condition, holds on an attribute which have same name in relation R and S, relation on which join operation is applied. While applying this natural join on two relation, there is no need to write equality condition explicitly. This natural join will also return the similar attributes once their values will be same for the resulting condition. This natural join is by default, it is also known as inner join, because the tuples which does not satisfy the condition of join does not appear the result set. For example, students whose roll number is equal to roll number of students sport. So here student, simply the join no need to put the condition and the next table, that is student sport. Here we do not have to use any condition, simply the name of the two tables and the symbol of join. So, it will automatically check for the same value and then it will display the respective values. That means, here we are getting roll number 1 Ram, Delhi, phone number, age. Up to this much it is coming from the student table, and sport part is coming from the student sport table. So, that means 1 record 1 roll number 1 whose name is Ram is playing badminton. Roll number 2, his whole record is coming along with his sport he is playing. Same thing, roll number 2 Ramesh is again playing badminton. Then roll number 4 Suresh, who is from Delhi, his phone number and age is coming and he is playing badminton. So, this is the result of natural join, and this natural join is also known as inner join. Next is the left outer join. So, while applying this left outer join, now it will check the result of the left hand side table, because in case of our join operation two tables are always involved, and this in these two tables it will check for the left hand side table. So, while applying join in these two relations R and S, some tuples of R or S does not appear as a result in which does not satisfy the join condition, but left outer join displays that result of R in result set. So, the tuples of R which do not satisfy the join condition will have the values of null for attributes in S. So, left hand side table it will display the result of common value as well as uncommon values, and for that uncommon values at the right hand side it will display the results as null. Then next is the right outer join, where just opposite of the left outer join. So, here the common and uncommon values of the right hand side table will be displayed, and the left hand side table for that uncommon values the left hand side table will be displayed for null condition. And full outer join it will display the common values of both the tables as well as the uncommon values also for both the tables. This is called full outer join. So, null value will be given in the respective tables after joint relation. So, it will display the result. Now, next is the rename operation. So, this rename operator is mainly used to renaming one table name or relation name. For example, before showing the example, this new operator is mainly used for this rename operation. Relation 2 comma relation 1 means relation 2 is the new name and relation 1 is the old name. As for example, new, when we are giving student 1 comma student, means student table was the earlier name and now we are giving the name of the table as student 1. So, student 1 is the new table name for student. There will be no student table exist when we rename the name of the table as student 1. So, this is the rename operation. And next is the division operator. So, this division operator is mainly applied for giving the division operator, the symbol is also divide operator symbol. So, here A divided by B can be applied if and only if attribute of B should be the proper subset of A, that means all the values should be present in A for B, and the relation returned by division operation will have the attributes equal, that is all attributes of A minus all attributes of B. The relation returned by division operation will return those tuples from relation A which are associated for every B's tuple. So, it is better to display these results by using an example. If we see this example, so here our example is given here. Consider the relation student sports and all sports given in table 2 and 3. So, by applying the division operator, so student sports divided by all sports. So, let us go to the student sports table first at the very beginning. This is the student sports where roll number and sports are coming here. Roll number 1, 2, 1 is playing badminton, 2 is playing cricket as well as 2 is playing badminton and 4 is playing badminton again. And we go to the next is all sports, where we are having the sports as badminton and cricket. So, if we give student sports divided by all sports, it will display the results of only those record where both the sports are available. Both the sports are available. So, let us see the student sports again. So, if we check here, both the sports are available. For which roll number we have to check over here. 1 is playing only badminton, 4 is playing again badminton, not cricket, but roll number 2 is playing badminton as well as cricket. And that is why the result will not be displayed for sports, it will be displayed for that particular roll number. So, if we see the result here now, we will get the result of roll number as 2. So, this is the result we are getting. So, this much for the relational operation or relational operator which are used in this as the in this DBMS. So, thank you for this, and before that let us go to the rough idea of this operators and all. So, I am going to give the firstly the revision now. So, firstly I have described about the introduction of the relational operation, why it is used. So, this is one kind of parallel act mainly, which is simultaneously used for the conventional processing, and for relational operation we use the relational algebra. Now, this relational algebra is the one kind of procedural query language which is used by giving some symbols. That symbols comes under this relational operator, that is selection. For selection the symbol is sigma, for projection the symbol is pi, for product or cross product the symbol is cross, for join the symbol is dumbbell, then for union the symbol is U, for intersect the symbol is reverse U, inverted U we can say, then the difference or minus the symbol is for minus, then rename the mu operator is used, and for divide the division operator is used. So, we have taken here, considering here 4 tables, and based on these 4 tables we have described each and every operators we have used till now. So, these are the operators and these are the examples, where the first one is the selection operator, where based upon the condition the records are displayed. Projection operator pi, based upon the column names the relations will be displayed. This one roll number and names are displayed, but no condition is applied. We can use some hybrid condition also based upon the selection and projection operator, where we can put the condition as well as the name of the columns. The next is the cross product, where it will display the result of 2 relations, which is the multiplication value. If the first table is having 2 records and the second table is having 4 records, then 4 into 2 we will get total 8 records, because 4 into 2 the result is 8, we will get the records. So, that is why we have shown this records here, these values here. So, these are the values. Next is the union, it will display the results of 2 relations as a whole, both common and uncommon values will be displayed here. Union, intersect, only the common values will be displayed. Minus, where first relations value which are not present in the second relation, so that will be displayed here. This is the example. Join operation, this is the Cartesian product based upon a selection operation. So, these are the types of join: conditional join, equi-join, natural join, left outer join, right outer join, and full outer join. So, different symbols are used based on that. So, each and every join operations are described here. So, the conditional join, equi-join, natural join, left outer join, right outer join, full outer join. And then next is the rename operation. This is the rename operator, where mu is used to rename one table to old table name to new table name. The old table name will not exist further. Next is the division operation. So, this is also described with the help of a suitable example of two tables. One is the student sports, another one is the all sports. So here in case of this division operation, one thing is very important, like only that value will be displayed which is not present in both the, which attribute is not present in both the tables. So roll number field is not present in both the tables, but sports field was available in both the tables. That's why it is not displaying the record of the sports table. So this much for today. Thank you so much. You have hope you have understood it very clearly. So thank you. All of you are very happy and good day. Thank you so much.